Jesse, don't do this! I'll be alright. I got my dragon, and he's got my back. And now I activate his special ability. You see, my rainbow dragon can absorb every crystal beast on the field. And for each beast it absorbs, it gains 1,000 more attack points.
Welcome to another episode of Math and Silly Hats. Today we're going to be continuing our series of solving systems of linear equations, this time with elimination, medium difficulty problems. It's going to be very similar to our process of solving those we did yesterday, only today we're going to have to rearrange and or multiply our terms to make sure we can eliminate a variable. So looking at this problem, in step one we want to rearrange the terms so we have the terms in the same order, x's, y's, numbers. So in the second equation we have x's, y's, numbers. But notice in the first equation our y is on the wrong side of the equation. So we need to make sure that this equation is in the same order as the second equation, in that we want both x and y on the left. So the first thing I'm going to do, I'm going to rearrange this equation by moving its terms around. So x is already on the left, that's fine. But I have this y on the right, it should be over here with x. So it's being added to 9. I'm going to use the opposite operation of addition. I'm going to use subtraction to move that y. So on the right, the y's will cancel and we'll be left with 2x minus 9 equals 9. So all I've done is I've rearranged this first equation to form this equation. Now in step 2 I might have to multiply one or multiple equations in order to get opposite coefficients. But here I have y and negative y. So when I do step 3, add these two together, I will end up eliminating a variable. So let's go ahead and move on to step 3. Add these equations together. So I would like to add our second equation and our new form of the first equation together. X and 2x will make 3x. Positive y and negative y eliminate, and I'm left with on the right 12. So from here, this is very easy to solve. We have 3 multiplying an x. Since coefficients multiply their variables, the opposite operation of multiplication will be division. Let's divide everything by 3. 3x divided by 3 is simply x, is equal to 12 divided by 3 is 4. So we believe we found one of our solutions being x equals 4. Now, our next step is to substitute this value into either of these equations. I've cleaned this up, and you'll notice I erased the second form of the first equation just because I don't want to have a compounding series of errors. However, I'm trying to solve for y, and I notice that y is positive in the second equation, so I'm going to substitute our value of x into the second equation to solve for y. So we had x plus y equals 3. But we now believe we know the value of x to be 4, so instead of x, I'm going to write 4. From here, it's very easy to solve for y. I'd like to move all the constants together. So the opposite of addition is going to be subtraction. We'll end up with just y equals negative 1. So we believe we now have a solution. Our last step is to check our work, so let's simply substitute the values of x and y into both of our original equations and make sure we get true statements, equations that have a number equal to itself. So our first equation was 2x equals 9 plus y, where we had x as 4 and y as negative 1. On the left, 2 times 4 is 8. On the right, 9 plus negative 1 is 8. So this checks out. And we know that our first equation works for our values of x and y. Let's test our second equation. Substitute in x plus y equals 3. We believe x to be 4 and y to be negative 1. 4 plus negative 1 is 3. We know that certainly is equal to 3. So our solution works for both equations, and we know this is the correct solution to the system of equations. Join me again tomorrow, where I'm going to be doing hard problems where I'll have to both rearrange and multiply one or both equations so that we can then add, eliminate, and solve a system of equations. Have a great day, everybody. Bye-bye!